Hi everyone, welcome to this webinar on messaging with AMQP. My name is Tanmay, and this slide is available on at this URL on my GitHub profile. Uh, if you're not able to see the screen properly, please feel free to access the PDF from there directly. All right, let's get started. Today, we shall quickly go through what is AMQP, just a brief overview, and then we shall see how to use the Julia package AMQP Client.jl to do messaging with AMQP. And we shall go through some useful patterns which we can use in our programs. Uh, we should have enough time for Q&A, but as Sushil said, please feel free to interrupt, send messages in the chat box anytime. Yeah. Okay. So AMQP stands for Advanced Message Queuing Protocol. Um, so what AMQP specifies is the wire level protocol for AMQP, and it also specifies the logical components of a message broker. The message broker is the service that facilitates messaging, the one that implements AMQP protocol. So it specifies both the wire protocol and the logical components the message broker should provide. Uh, and with this, AMQP guarantees that any AMQP compliant client can connect to any AMQP compliant server and expect the same functionality and same behavior to be available, which is nice because then we are not tied to any specific implementation that we write. There are two primary versions of the protocol, which is available now, 0.9 and 1.0. So in the Julia package AMQP Client.jl, we support 0.9, which is still quite prevalent and popular. Um, so let's go through some AMQP terminology first, which we're going to hear quite a lot in this presentation. And all this relates to 0.9 AMQP version. So a broker is what implements the AMQP specification, right? So it is the messaging server. A virtual host in a broker is a logical view or a partition of the broker. So a single broker instance may have multiple logical partitions, each with a different configuration, and it can hold different queues and such. So a program actually, when a program talks to a broker, it is actually talking to a virtual host of that broker. So a program talks to the broker via connection, which is a TCP connection, TCP network connection. And when it talks over a connection, it uses something called a channel, which is again a logical concept. A channel allows a client to have multiple contexts, similar to the server context, which is the virtual host. The client also can have logical context, which is the channel. And uh, so a connection allows multiple contexts to be multiplexed over it. So imagine different tasks in a program, and each with its own channel. So all the tasks can communicate with their own channel using just one connection. Normally, we do not need to use multiple connections unless we need very high bandwidth, which one single connection cannot give us. Uh, Next, exchanges are message routers. Exchanges, depending on the type of exchange, exchange can route message differently to queues. And the queues hold messages until they're consumed by a client program. And finally, a message is just a blob of data with some name value pair attributes. We shall see details of these as we go on. Um, Uh, Now, how to get an MQP server? There are many server implementations available, but I'm going to mention only RabbitMQ here because RabbitMQ has been around for quite some time, and it is very mature and stable. It is available in a variety of platforms. The easiest to try out, in my opinion, are the managed ones. So there is one provided by Amazon, which is called Amazon MQ on AWS. Cloud AMQP provides the same thing on almost all major cloud platforms on Azure, EC2, on GCP, um, and there are many others as well. And if one would like to host it on their own infrastructure, they could use the Docker image from Docker Hub, or you could download the binary and install it. So the RabbitMQ website has a extensive list of different options available to install RabbitMQ. Now let's come to AMQP Client.jl. Uh, it's an open source package. It's available at this URL, and just like any other Julia package, you can just use the Julia package manager to install it. Um, the first thing that we need to do before we can send a message is to connect to a server. So we connect on a network port. Um, and for AMQP, the default port is 5672. There is also AMQP-S available, which is AMQP on TLS, and the default port for that is 5671. So in this example, I'm just using AMQP because that's the easiest to set up for anyone to try out. And when we connect, we need to authenticate. So AMQP supports different ways to authenticate to the server. Um, in AMQP client, we support only the AMQP plain authentication protocol, where one can authenticate using a login and password. Um, so to connect, we use the connection API. We specify a virtual host. We specify where our server is, the host and port, and we specify the authentication parameters. If it was uh, AMQP-S connection, then we would have to specify some TLS parameters as well, which is there in the documentation. Uh, as you see, the connection API follows the Julia do syntax. So once we connect, we get a connection which you can use in the scope. And once we exit the scope, the connection is closed. On a connection, we must then open a channel, which is the client's context of communicating, right? So we get a channel using the channel API, which is very similar to the connection API. Follows the Julia do syntax. We pass a connection, and then we can ask the server to allocate any unused channel here. That's what we are doing. We are asking the server to allocate any unused channel to us. A channel is nothing but a number, integer. We could have also specified a channel number here. And the last parameter here says whether the server should create one if it is not there, or should error out. So we are passing true, saying if it is not there, please create it. If it is there, just use it. So after this, we would get a channel, which we can use in our in the block. Okay, so once we have a channel, we can now talk to the broker, right? So we can now request it to set up exchanges and queues for us to route our messages and store our messages. So here I have a function called prepare queue, to which I pass the channel. And here I'm asking the broker to declare an exchange for me, which is named direct exchange 1, and it is of type direct. There are different types of exchanges, as I had mentioned earlier. We will see them in detail further down. In this example, I'm just going to use the direct exchange. So if this succeeds, I'll have exchange named direct exchange 1, and then I'm declaring a queue called Q1, and then I am binding the queue to the exchange, specifying a route. So if you remember, we discussed that exchange will route messages into queues, right? So here we're asking the exchange to keep any message meant for this route into this queue. All right. So we created these queues and exchanges to work with. So when we are done with them, we must destroy them and clean up. To clean up, we just do the reverse. We unbind the queue and we delete the queue and we delete the exchange. That's it. Uh, so if we put this into a skeleton code now that we had to connect and create a channel, if you just call this prepare queue and tear down queue methods within that, we should see these kind of messages, info messages printed out. The channel is opened and exchange is declared, the queue is declared, queue is bound, and finally we are unbinding and deleting everything. Okay, so this is probably a good point to talk a little bit about durability and persistence in MQP. Uh, so exchanges and queues can be designated as durable. What this means is they will be restored back to the previous state in case the broker crashes and is restarted. Um, Similarly, messages can be designated as persistent, um, which means that they are checkpointed. And if a message is not acknowledged by somebody to whom it was delivered, the broker is going to attempt and re-deliver it. So a persistent message routed through a durable exchange onto a durable queue is reliable. That is how AMQP uh, provides reliability of message. Now let's see how to send and receive messages. Here I am defining a new function called send receive message. Um, so as we discussed earlier, message is nothing but a blob of data. So I'm creating a blob of data using the string called hello world, and I'm adding some attributes to it. So here, if you notice, I'm marking it as persistent. Um, and then I'm using the basic publish API to publish it onto direct exchange one, and I'm specifying that please use the routing key route one. So if you remember, we had registered the QQ1 on this exchange with the same route. So this exchange is going to put this message into this queue. And when we use the basic get API next to fetch a message, we should get the same message back. So in this example, if you notice, I am having the publisher and the consumer of the message in the same function, which is not practical. I mean, normally they're totally different processes. But just for example's sake, I've just put this into the same message. So usually the publisher will be a separate process here from here, and this part will be a separate process, the consumer. And now if we plug this into our previous skeleton where we had prepared the queue, uh, we just use this method to send and receive messages. We should see these info messages getting printed out. So the message is published and it is also received, and then we clean up. All right. So in the previous example, when we went on to receive a message, we were sure that there is a message available because just before that we had published a message, right? But that is usually not the case in a practical program. So a consumer does not know when a message has been published. So we need something async there. So the consumer should be triggered, right? Um, so that can be done by registering a method as a consumer. For that, we can use the basic consume API. Um, so this is where I'm registering a consumer for Q1. And this is my consumer method. I'm just printing out the message that I got, and I'm acknowledging the message. The rest of the code is the same except some flag for to indicate whether the message has been received or not. We are still creating the same message and we're publishing using basic publish. So this is how we can set up an asynchronous consumer. And sure enough, if we plug this into our skeleton program, we will see the published message getting received asynchronously. And finally, we cancel the consumer and unbind the queue and clean up. All right. So the canceling the consumer actually deregisters the function from the queue. Right? That's what basic cancel will do. So when we register a consumer, we get the consumer tag, which is a auto-generated ID for the consumer by the server, by the broker. So we can cancel the consumer anytime by specifying the same tag. All right. So let's see if there are any questions at this moment. There are none. Okay, let's proceed. Okay, let's see some useful messaging patterns. Right. So first, let's cover some of the messaging patterns that the exchanges provide by default. We had mentioned earlier that um, the exchanges can be of different types, and based on the type, they will route differently. Right? The simplest thing that we can do on with any messaging thing is publish and subscribe. So it is one to many. A publisher will publish a message, and they will publish messages which are tagged, and the receivers will receive messages based on the tags they have subscribed to. So when a publisher sends something to the exchange has some rules to filter out messages, and based on those rules, they filter messages and send to different queues. And the consumers who are attached to that queue will receive those messages. And the rules, the abilities of the exchanges to filter, that is what differentiates the exchanges. Uh, so a direct exchange will do a direct matching of the routing key to do the filtering, to do the routing. So um, it'll match the routing key exactly. Whereas a topic exchange can match patterns in the routing key. Okay, it is slightly more advanced than the direct exchange, you can say. And the header exchange also does pattern matching, but it can match patterns in the headers of the messages, right? So headers are the name value attributes of the messages, right? So if you see, they all do very similar things. They just apply some rules and route the message, but they're different just on what they apply the rules on. The next pattern we can get is the fan out pattern, which is the same thing, except that there are no rules that are applied. So uh, all the messages that a publisher publishes to a fan out exchange are pushed out to all the queues that are attached to it. Even if a routing key is specified, it will be ignored if it is a fan out exchange. Very simple. This is what the basic the exchanges provide us. On top, using those, we can build more complex patterns. One interesting patterns is the RPC pattern. RPC is remote procedure call. So here there is a client, and there's a client program, and there is a server program. The client wants to send a message to a server and expects a response for that message, right? And the response must come back to the same client that requested. All right. So if there is client A and client B, if client B sends a message, the response to that should come back to client B. And if client A sends a message, the response to its message should come back to client A. Now we can do this simply by using direct exchange. So the way we can do it is we define a server queue, and both the clients, they send their request to server queue, and the server process uh, reads from the server queue to process messages. But what the client does is the client sets two attributes in each message. One is the reply to address, where it sends a routing key or a queue name um, to which the server must send a reply to. So when a server is responding, it will attach that routing key, or it will send to that queue. So that it comes back to the same client. The client can also attach another attribute called the correlation ID, uh, which the server just copies back to the response. So correlation ID is like a message ID. So this using this will allow asynchronous processing of messages. So the client can just keep on passing messages with different correlation IDs, and the server can process all of them asynchronously and send them out on this queue. So when the client receives, it can correlate the response belongs to which message. So if you see, we are able to do RPC using direct extension simply. Then we can have a work queue. Um, so in a work queue, one or more feeder processes push out messages into a single queue, which is a work queue. Then one or more worker processes consume messages from this work queue, they process it and do whatever they have to do with those messages. Now, if a worker process gets killed, dies while processing a message, it will not have it would not have uh, acknowledged that message. So if the queue is designated as if the message is persistent, designated as persistent, it will be resent to another worker. So that's how there'll be reliability in the work queue. There is one more interesting thing that can be done in a work queue is a queue monitor. So what a queue monitor can do is it can sit by the side and monitor the size of the work queue, and based on the size, it can vary the number of workers in the pool, so that uh, uh, the the message processing latency is controlled. So there is the, there will be a balance between the message processing latency and the number of idle worker processes that are allowed to be there. So this is how we can do a work queue, and here again it will be a direct exchange that we're going to use. Um, there are several other patterns we can imagine. We can build on this framework. One is the splitter. Splitter is nothing but a batch processor. So given a batched message M, a splitter can split it out into component messages A, B, C, D. The aggregator just does the reverse. It batches messages. Given a series of messages A, B, C, D, it can batch them together into a batch message M. A sequencer can resequence the messages. It can, for example, it can apply priority on the messages. So if it receives a series of messages, it can apply some priority and change them to a different order. Enricher can add more information to the messages as messages pass through it. So for each message that passes through it, the enricher can add more attributes or change the message content depending upon what it is supposed to do. And a filter will just pass, will just let only some messages pass through it depending on their filtering rule. uh, Wiretap can transparently route messages out of can transparently duplicate messages what are passing through it to be consumed by something else. So you could do, for example, logging or route messages to a different program through using a Wiretap. Service activator is something similar that we saw with the work queue. So it would examine all the messages passing through it. It would either examine or count messages passing through it and based on some event, either number of messages, the size of messages, or some content, it can trigger some service, it can activate some service. So these are the few patterns I found useful while working with message queues. um, yeah, that's all I had to talk. If there are any questions, uh, I'd love to take them on.
Yeah, you can either type in the questions in the chat box, or you can unmute yourself and ask the questions if any.
Right. So there is a question on slides. The slides are available on at this side place. I'll just go to the first page. Yeah, the slides are available at this location.
Tanmay,
And
can you copy and paste in the message that people can then?
oh yeah, sure. Yeah,
Yeah.
sorry. All right. And so there is a question on what data types can be included in the message. Any Julia value struct, or does the data need to be packaged somehow? So the data needs to be in byte format. So you could pass any data. You could also pass a Julia struct if it is serializable. So you could just serialize the struct into bytes and pass them on. As far as the AMQP infrastructure is concerned, it only deals with bytes. Okay, there's one more question. I'm more familiar with zero MQ. When deciding on MQ, what considerations should we think about? When would we choose AMQP versus zero MQ, and which is used more in practice? Uh, okay, I think both are used equally. So uh, I'm not sure how rich the routing possibilities are with zero MQ. Uh, you probably have to write some code to examine the messages and do your routing. But some of those, it is more flexible, definitely. But some of these are already built into AMQP, is what I believe. So if your routing need matches what AMQP provides, then it is probably simpler to use AMQP. Zero MQ is much lower level, I would say. Um, so that's those are the differences, in my opinion, at top level.
Yeah, please type in your questions if you have any in the chat box, or you can unmute yourself and ask the questions as well. Okay, looks like we have no more questions. Perhaps we can end the session here. We will, as Tanmay mentioned, you can access the slides in the link he provided. And in a few days, the video of this webinar will be up on Julia Computing website. You can view it there as well. And in case you have any questions, you can always write into us, and we would be happy to answer them. Right. Thanks a lot, Tanmay. Thanks for your time today. And there's one question. Are there any demo
Yeah.
codes?
Right. So yes, there is a demo code for RPC setup, I think. I let me do one thing. I'll have to figure out which repo it is there. It is definitely there in my GitHub account. I would post a few notebooks maybe with that example on the same repo where I have shared the slide. I can do that tomorrow. Yeah. Thank you, everyone. Any other questions? Just wait a minute and then probably
Yeah,
close.
let's wait a minute and then we can end the session.
Uh, there is one more comment there. Would you add links for the examples to your slides or send them out by email? Uh, yeah, definitely. I'd probably prepare a set of notebooks for each of the examples and then publish them. I hope that will be good. Right. Cool. Can I mail you in future? Oh, sure. Please feel free to mail me or request me on GitHub. Yeah. Is there a blog or discussion group? There is the repo AMQP client. If you need anything, you can raise an issue, or you can email me directly also. Sure.
Okay, looks like there are no more questions. Shall we end the session here today, Tanmay?
Yeah, sure. Thanks a lot, everyone.
Okay, thank you,
Uh,
everyone.
Thank you, Sanjeev.